So the first talk we're going to have tonight is from Rajeev. So Rajeev is from AWS and he's a principal specialist solution architect specializing in IoT and edge computing. So awesome, of course, to have an IoT specialist, but edge compute is another sort of emerging technology that is very closely related to IoT. So that's awesome to have Rajeev here. He's also a member of IEEE. And, I shouldn't say this, but he's got decades of experience, including some patents in the US. So that's pretty spectacular. So we're really excited to have Rajeev here today.
Thanks a lot, Michelle, Steve, and Ali, and nice to be here. Sorry about those glitches. I think 30 years of computing and we still have problems with video and screen share. Anyway, thanks for that intro. I'll quickly jump right in and maybe just give a little bit of background of what we are going to cover here. As Michelle said, I've been with Amazon for about 1.5 years now. Prior to that, I spent about 18 years at Intel, doing several things in software-defined networking, wireless chipsets, standards at IEEE and IETF, and low-power devices, and also spent 1 year with Telstra, building some of their narrowband IoT devices and cloud platform, IoT cloud platform. So what we will do sort of in the next 25 minutes or so, I'll try and keep this quick in the interest of time and the next speaker as well. I'll start with an initial overview of some of the things that people are doing with AWS IoT and portfolio of products and services, and especially looking at industrial IoT use cases. I think that's an emerging trend that's getting a lot of momentum here, and you'll hear all kinds of terminologies with Industry 4.0, edge services, mobile edge computing, and all of that. So try and demystify some of those terminologies, as well as what some of the capabilities are with AWS IoT that we can start building today with industrial systems. So that includes manufacturing, agriculture, energy and utilities, etc. And then moving on beyond AWS itself and the portfolio of products that we'll talk about, I want to touch upon sort of a landscape of the technology trends that are coming up in industrial IoT. I'll talk about some of those trends, standards, as well as a very interesting area that's personally been very passionate about, and that's TinyML, which is bringing AI down to microcontrollers. And if time permits, I will bring up this small device here. It's a small ESP32 microcontroller that has a camera. It can run TensorFlow Lite on this. It runs Amazon FreeRTOS and can do face detection and wake word detection. So it can detect audio samples and then do some things with it. So if time permits, we'll get to that in the end. All right. So I think one of the key things is that IoT is not technology for technology's sake. And what we are largely seeing across the world today is that people don't just buy technology in IoT. They want to do improve business outcomes. They want to improve efficiencies. They want to improve productivity. They want to be able to do new things like quality and monitoring much faster, better. And that's why putting all the portfolio of services, as well as not just devices that sense, but data that comes out of it. And there are some very interesting people here that I got to talk to just before we started with the talk. Remote patient monitoring, health monitoring applications, devices that not only detect that a person is breathing and what his oxygen capacity is, but also whether there are some alerts that need to be raised based on some intelligence that you can run on the devices. Industrial process improvement, productivity improvement, tracking inventories, autonomous systems and connected vehicles. I think all of these areas are trends that we are seeing worldwide. And there are some very specifically that are of high momentum here in ANZ. And maybe some of the things that I will touch upon later, some use cases and some partners that are working in that space, especially in agri-tech, in industrial use cases, and safety, workplace safety, and with COVID especially, all of that is taking a lot more importance with remote monitoring, facial detection, thermal cameras. All of that stuff is now getting into real production and deployment. So that's a broad range of things that people are doing, and I'll maybe touch upon some very specific ones in the industrial space. One of the biggest deployments we have in the energy sector is with Enel in Europe. I think they're based in Spain, if I remember right. And this is with a large-scale energy network distribution and sensors and meters that collect energy data, consumption, monitoring network behavior, as well as doing some real-time tracking of seismic waves, earthquakes, and other environmental conditions. So this is a classic case where they have lots and lots of sensors, hundreds and thousands of them spread across hundreds of square kilometers, gateways, intermediate gateway nodes that run Amazon IoT Greengrass. That's our edge computing software, which I'll talk about in a little bit. Process all of that data both at the edge on those Greengrass nodes as well as in the cloud, and then with the ability to respond to anomalies and act on data that's coming in at real time. So that's in the energy sector. There's another one, Moixa, which is very much into batteries and sustainable energy development. So this is the area of microgrids and smart batteries and solar panels. And you would have seen Tesla's announcements about large solar battery farms to be built here in Australia. The second one, I think, if I remember right. So all of these require large-scale sensing data, acting on that data, both in flight as well as at the edge in the cloud. So this is another sector where we have seen a lot of investment. Another example based in Japan in the core manufacturing setup is Shimadzu. They have microcontroller systems that do everything from high precision medical equipment to hydraulic equipment, vehicle, differential gears and all those kind of systems, hydraulic devices. All of these run FreeRTOS, which is one of the biggest embedded RTOSs out there. These devices run with 4G connectivity, and we'll talk about this in the industrial IoT trend a little later about private 4G networks and private LTE networks, and how that trend is coming into the industrial space, whereby private networks as well as private hybrid partnerships between industries and telcos are now coming into place to be able to do low latency computing both at the device as well as the edge, and then real-time transmission of data back into the cloud. One of the biggest collaborations we have had in the industrial space is with Volkswagen. And this was a huge goal that they set out a few years ago. And the plan was to improve production efficiency across all of Volkswagen's about 122 factories and 35 brands in the next 4 or 5 years, and improve that by about 30%. And what they're doing is an open industrial cloud platform, which includes the ability for partners, gear manufacturers, hardware vendors, all of these guys to put in their systems, their devices, their sensors, their hydraulic equipment, all of these things into the cloud platform for supply chain, manufacturing, real-time data, as well as monitoring all of these things and complete production line monitoring and optimizations. So this is something that has gone live in the recent past. You might have seen some announcements about this a few months ago. And this is one of the biggest partnerships in the industrial IoT space. And I think this is going to be a game changer in the automotive and manufacturing space. Moving into another very interesting area, and we are seeing a lot of momentum here in Australia and New Zealand. I've been talking to several different agri-tech companies here, and 30 megahertz is one such. They do real-time crop monitoring, so sensors deployed in their greenhouses, doing moisture, humidity, pressure, temperature, all of that sensing. And these devices connect over 4G or a backup 3G connection and send data into the cloud and do some kinds of data and predictive analysis, prediction of weather, turning on sprinklers wherever required, all of that kind of, bringing information and action back down to the devices and the edge. So that's a very interesting space. Local, we have a partnership. We have a partner called BigMate. They have developed this new post-COVID time, actually, this is in the last few months, thermal imaging camera solution called Thermi. This is what it looks like. This can be deployed in airports, in railway stations, and they're doing this now as we speak in building entrances, large buildings. And the idea is that as you're walking through the stiles, it will do real-time temperature sensing, sending information back to the cloud, and wherever required, maybe if the temperature changes in the environment based on ACA conditioning, it will download newer machine learning algorithms to adjust the temperature sensitivity ranges, for example, or download new profiles to be able to do that. And this is based on another product that they had called Warney. And the idea with Warney was that it uses sophisticated computer vision algorithms deployed at the edge to be able to do safety monitoring in industrial places. So you can look at whether a forklift or a machine is coming close to a human and then raise alarms or take some predictive action. So that's some very interesting work happening there. I think somebody here in the table that I met talked about autonomous vehicles and connected vehicles. So vehicles today are a source of enormous amount of data. A typical hybrid vehicle today, maybe even a 4 or 5 year old vehicle, generates about 25 gigabytes of data per hour. So you're looking about, a few terabytes of data in a day of driving. So all of this stuff is now being captured by newer electronics and gear systems, enabling vehicle to vehicle, vehicle to infrastructure, which is smarter transport ecosystem, roadway gateways that are connected to a telco cloud that can give you more real-time traffic information, for example, and put that information back down to the vehicle. So these are emerging technology standards. And the idea here is, there's multi-access edge computing, and it's called CV2X, cellular vehicle to X, so vehicle to vehicle, vehicle to infrastructure. And all of these things are very core part of our products and portfolio. So you have FreeRTOS devices that are gathering data from the cars and different parts of the sensors, Greengrass running locally. This can be doing local machine learning algorithms, connecting data, analyzing the data, and then using the telco cloud to actually send the data into the cloud and do low latency inference. So with that quick overview, I think most of the conversations that we start with IoT is about this question fundamentally. And that is, if you know the state of every single thing that you have, a device, a sensor, or whatever that might be, and could reason on top of that data, what business problems would you be able to solve? And that is sort of the foundation for all the frameworks, architectures, and patterns that we've been working with customers. And there's a lot of learning here. And what I would like to do is take about 5-6 minutes to talk about some of the foundational components of AWS IoT and just a very high level overview of some of the products and portfolios we have there. To start with, fundamentally, and Michelle and Steve talked about, battery-powered sensors that can look at, whether you're moving, you're fallen, or something like that. These things have constraints. So energy constraints, network latency is another constraint, bandwidth is another constraint, and obviously price point is a big one, because you don't want to have to replace batteries and change the device every few months. You would rather put it in a AA battery or a couple of them and leave it running for a couple of years and not worry about it. So fundamentally, if you look at what are the different connectivity options, and some of these things become a foundational discussion about what are the kinds of devices you want to use. If your devices have the ability to have a long-range connection and a higher bandwidth, then the kind of device and the kind of data it can capture will sort of become, will have a different factor to it. So what you see here is a sort of like a high-level view of the different network and connectivity technologies. I won't go into this in too much detail, but the idea is that there are several in the longer range, medium range, as well as the short range wireless and connectivity devices and protocols. And here on the y-axis are the data rates. And obviously, several of these these things each of them work in different conditions. NFC, Bluetooth, BLE, all of these work in more short range devices. whereas Wi-Fi or mesh networks start to bridge the gap between smaller distances to connecting into an edge or a cloud that is reasonably close by, within sort of a kilometer range or something like that. However, as we get into longer range networks, so this is where things like LoRa or narrowband IoT, which can go into tens of kilometers, and now Telstra, for example, has deployed NB-IoT networks here in Australia in several areas. And narrowband IoT is something that was defined by 5G standards as part of 3GPP, but that is now evolving into more powerful IoT technologies and protocols. And I'll talk about that in a little bit, which come into the 5G IoT space. So that's the longer range, much higher bandwidth and throughput that enables more industrial use cases that we will talk about. And of course, there's the satellite and the really long range connectivity options there. And we have some interesting partnerships and products there with Iridium Cloud Connect, companies like Myriota based here in Adelaide, or Fleet Space based here in South Australia, or I think Sydney. They also do a combination of long range and short range connectivity options, where the long range is low Earth orbit satellites. With that said, the AWS IoT services sort of have this circle of life, if you will, life cycle of an IoT device, whereby the bottom right is really device software. And I mentioned FreeRTOS, and FreeRTOS is one of the MIT open source, publicly available operating system. It's probably powers about 30+ percentage of microcontrollers. Amazon FreeRTOS was Amazon version of that, which we have now contributed completely back into the community. And we have the senior principal engineer, Richard Barry, who is now on Amazon. He's an Amazon employee. He drives the Amazon FreeRTOS development, completely open source. And we also have a version of that called SafeRTOS, which is for automotive grade, mission critical, safety critical systems. So really small devices that need to do aggressive data processing in a very safe and secure manner. We also have Greengrass, which is the sort of the next bucket of computing, which is all the devices talking to an edge. And IoT Greengrass is can be a software Docker container that can run on a rugged Linux platform, for example, that will be your gateway to the cloud. And the rest of the control services sort of become the rules that you can process on MQTT messages, put all the data that's coming on the stream of network connectivity into data store, process them over using serverless functions. If there are video streams, use Kinesis video or some other artifacts like that in the cloud that you can process real time and derive some meaningful information out of that. So all of that come into the control services. I won't go into all of these in detail today. We'll touch upon a little bit into the more interesting ones from an industrial perspective, which is Sitewise and IoT Analytics, which are more industry grade, specifically for industrial data processing. And I'll talk about that in just a little bit. Yeah, I talked about FreeRTOS, so we'll skip this. We have a lot of new things coming here. We have about 20 or 25 silicon partners that we have been partnering with, introducing newer and newer connectivity technologies, as well as sensing capabilities from different vendors. And the idea is that we have this continuum of products from the devices all the way into the cloud. And quickly touching upon Sitewise and Analytics, the idea here is that IoT Sitewise allows you to ingest equipment data from legacy devices and OPC UA or Modbus or Profibus. These are your standard industrial SCADA systems. And the ability to integrate the cloud component into that is very powerful. So this is what Sitewise allows you to do. And then it will allow you to model your data set, store them, do time series data forecasting and data modeling, and then derive some intelligence out of that, which could be predictive maintenance or predictive quality or asset monitoring. And the idea here is that you can have either devices that are connected directly into the cloud, the ability to send data over MQTT TCP stream, or if they are legacy systems, then you can do custom protocol conversions, convert UPC, UA, or any of these other protocols, into something that's more compatible with the cloud, or you can run your own sort of data conversion, protocol conversion mechanisms, and then send them into the cloud and then monitor and do data processing with that. IoT Analytics is another component which allows you to bridge the data and the real-time information processing, visualizing, reporting, analysis, all of that with a very easy-to-use toolkit. And literally, when I joined Amazon, it took me within literally a day or two to put all of these pipelines together and have advanced analysis capability, time series forecasting or prediction. Fairly easy to use. And the idea here is that starting from the device, as I said, to quickly summarize the portfolio of services, we have FreeRTOS and Greengrass on the device side. We also have Alexa voice service integration. So in the case of, for example, personal health devices or smart building infrastructure, things like that are important now in the post-COVID world, you can integrate that with Alexa very easily. We also have a machine learning at the edge with SageMaker models that can be deployed to Greengrass. We also have the Snowball series of products, which are ruggedized devices where if you have constraints on, hey, this amount of data needs to stay in the on-premise equipment, then we have either Snowball Edge, Snowcone, or Outpost. So these are devices which will make sure the critical data, the secure data stays on-premise, and the ones that you really need to move into the cloud can go move it into the public infrastructure, into the cloud, as well as through the telco infrastructure. And that's AWS Wavelength. I'll not go into that in too much detail, but that's one of the trends in industrial IoT, which I'll hopefully touch upon very quickly. I think in the interest of time, I'm going to skip through a few slides here, given that people are potentially very familiar with some of the use cases in industrial IoT space. I'll just flash through some of these slides and then quickly get into how some of these technologies can be used. So for example, workplace safety is something that I mentioned, that we have solutions that are being built by a lot of customers and partners, where you have facility cameras that can do people tracking, temperature sensing, deploy machine learning inference to the devices close by, so that the devices in the shop floor, in the industrial floor, can also be acting intelligently and do some amount of predictive maintenance or anomaly detection. If somebody's close by, then have the person have that forklift move away, for example. One of the biggest things with industrial data is that industrial IoT data has just been locked up in legacy systems. And this has been the first problem that we wanted to attack and get, provide a solution that's easy to use. And as this slide shows, when an industrial partner wants to come into move their data into the cloud or start doing something intelligent, the biggest problem is the number of protocols or the diversity, proprietariness of these systems. And that's really a lot of undifferentiated heavy lifting from that perspective. So what we've done is, and I'll move quickly into actual solution here, is develop what is called a connected factory vision and connected machine framework. And the idea here is that you have different industrial devices, and those are the devices at the bottom here. And the concept is that you want to plug in these devices, either legacy systems, or if they are standard protocols like OPC UA or Modbus, then provide an ability to ingest all of that data into the cloud directly with minimum amount of work to be done by the industrial customer itself. And what we have done here is worked with industrial partners like Ignition or Kepware, where they provide software, and we've partnered with hardware vendors to provide industry-grade equipment which can interface with historians and SCADA systems and PLCs, or in the case of custom protocols, then we provide software components where they can be converted easily and then shipped into the cloud. And the rest of the cloud here, I won't go into that, but that'll allow you to do data processing, which is extract, transform, load, ETL processing, do video analysis, or do whatever else you want with the data coming there. And that's an open source, openly available framework, CloudFormation, cloud templates that somebody can try out and use that. So as I mentioned, we have several different hardware partners that do this, software partners, and then complete ecosystem deployment people, right? So people like Tensor IoT or Hitachi, all of these people provide complete solutions. They'll come and work with the industrial partners to understand what they need to do and then build the whole solution. So like, for example, this is a solution from Lenovo, really industry grade. This works with AWS IoT on one side and SCADA systems, CAN bus integration, Modbus integration, all of that stuff on the industrial side of things. So with that, I will stop for just a little bit to see if there are any questions. I might need another 8 to 10 minutes, if that's okay, Michelle, Steve, and Ali, to finish the other topic.
Hey, Rajeev, we do have quite a lot of questions here. We are on a bit of a time frame as well, so we probably don't have an extra 10 minutes, but we'll get through these questions and see where we're at. The first question here for you is, which of those IoT networks do you think has the best security?
So I think security is an interesting one. Each of those networks come with their own different security parameters and patterns. I think the cellular space has evolved a lot in the last 20 years or so. So fundamentally, the idea of having SIMs and a trusted authentication between the SIM as well as a base station and a telco provider has provided a foundation there. Now, that said, a lot of the other networks like LoRaWAN or satellite networks are also coming up with several different connectivity, security protocols and frameworks, whether it's either at the protocol level like TLS or the ability to do things like eSIM, but in a more different context, whether it's a LoRa device or a satellite device. So, yeah, I think it's emerging. It's a technology that's emerging.
Yeah, awesome, man. Thanks for the really thorough answer. I really appreciate that. We've got one here from Farshad. Is there yet an equivalent of Azure Edge Zones in AWS
that was AWS
Cloud
Wavelength, which I didn't talk about then, but I'll come to in the next part when I'm talking about industrial IoT, because that's really bringing the cloud to an edge of a telco and into an industry, closer to an industry, to reduce the latency. So low latency IoT is where AWS Wavelength plays the primary role, and that's the equivalent of Edge Zone here.
Awesome. I think we might have to get you back for a second talk, actually, Rajeev, so that we can fit everything that you want to talk about in, if you don't mind doing that. Another few questions as well, so we're getting a bit over time here. But do you think MQTT or XMPP is better to use for LPWAN?
MQTT traditionally was designed to operate over TCP, which is a connection-oriented, dedicated. The idea is that it's a reliable network, a reliable connection. However, with LPWANs, that assumption does not hold true always. So your device may be moving, you may be in an area where you don't have network coverage, you might be inside an industrial shop floor where you don't have telco coverage, 4G coverage. So what has happened is MQTT over TCP has, while it's been good for managed networks like Wi-Fi, we have a different set of protocols like CoAP, which is Constrained Application Protocol, that works over UDP and an equivalent security protocol called DTLS, datagram version of TLS. And that has become very popular with devices because that is very, very spectrally efficient. The overhead of the packet size versus the header size is much more optimal when you look at CoAP and UDP versus MQTT TCP. So long answer, sorry, but yeah, they're happy to go deeper into that again.
No, that was great. And we do have networking at the end as well. So if anyone does want to hear more from Rajeev, we will be around at the end. So just jump on his table and ask him those questions. 2 more quick questions here. Stop adding, guys. Though, we love that you're all really involved in this. And thank you, Rajeev, for getting such interest and engagement here. So next question, are there plans to add any new regions in Australia, given Azure has 4 in Australia?
So look, the answer to that is AWS and Amazon looks at every region and the customer space and a lot of different factors, availability of sustainable energy, renewable energy sources, a whole bunch of different factors. And long story short, there's a lot of work going on in that space. I can't, unfortunately, give a more specific answer.
Yep, fair enough. It's always the way. Last question from Yeshi as well. A few best practices for ensuring security of the SCADA system as it is connected to
Look, yeah, that
analytics.
can be very specific. So as I mentioned, if there is important data that cannot leave your shop floor, your industrial plant, then obviously that data will just be right there. You don't want to play around with that and ship it over to the cloud. But if you're talking about network layer security with data going from those SCADA systems into the cloud, then those conversion layers that we talked about, right, whether it's Ignition or Kepware or any of the other systems, they do the required work using Amazon Greengrass to use TLS 1.2 x 5.9 certificates, certificate rotation into the cloud, so that you never, you maintain the best security practices, so to speak, right? And some of that link that I pointed there, and we'll give these slides out as well. You can go and look at that framework and explore that for yourself as well.
Amazing. Thank you so much, Rajeev. I'm really sorry we have to cut off the end of your talk here, but we are definitely going to line you up to finish off the talk next year, I think. I hope, if that's all right with you. And we did have a message in the chat. So David would love to see some similar slides as you showed earlier, with the power costs and unit costs as other dimensions. It's a great summary, he thought. So I'd love to see that as well. So if you do have some slides on that we can pass out to the participants tonight, that would be amazing. Thank you. Thank you so much again, Rajeev. That was an amazing talk.
No,
and again, sorry to cut you off.
I just overestimated. Yeah.
No, it happens. You're just passionate, and we love that from our speakers. So thank you so much for sharing with us all. Next up, we have the awesome Joshua Morley. So Rajeev, you're able to turn off your camera, microphone, and share screen. Thank you very much. Next up, we have Joshua Morley. I met Joshua about 3 or 4 years ago now. We were both at university at the time doing a Google Ambassador program. Now, Josh has always been super passionate about sharing his learnings and ideas, and really passionate about tech. So he's now an IoT principal at Modus and a full technologist. I totally agree with that statement. And he's got an awesome talk to give us on implementation, how to solution design and implement a new IoT project. So I'll let him discuss that because he knows best. Thank you so much for joining.
Thank you very much. Can everyone hear me all right?
Yep, all good here.
Yep. And is my screen successfully shared?
That too. Yep. Perfect.
Awesome. Cool. So innovation is just creativity applied with technology. Sometimes it's hard for people outside of development to see how creative writing code or architecting a solution can be considered creative. But if you show a novel architecture or a bespoke algorithm to another developer, guaranteed creative is among the words of praise that you'll hear. I find it really interesting when referring to the same algorithm or architecture, somebody from another field might refer to it as innovative, which led me to realize that innovation is just creativity applied with technology. And innovation is really at the heart of IoT. Whether your motivations are business value driven, humanitarian ambitions, or to satisfy the deep and driving curiosity that many of us in the field have, we all push boundaries and innovate by collecting new intelligent insights from things previously considered mediocre. My friends and family from other fields have often said it's difficult to succinctly describe what it is I do for a living, and I have the same problem. So I guess I'll kick off with a little bit of background about me before going into the main core of the speech.
Just to interrupt quickly, is it possible to make that Prezzo a little bit bigger?
It's on my vertical screen, so...
okay, cool. No, that's all right.
Hang on, I'll just swap screens to make that easier.
Also, love your chair. Just saying, was spotting it.
Thank you. Alrighty, and I'll just share again.
Also, big fan of the vertical screen because for coding, that actually makes sense.
100%. Hang on, let's pull this over here so it's out of the way. How does that look aside from that
Amazing. Thank you.
That's much better. Awesome. Cool. So g'day everybody. My name is Josh and I'm a bow tie enthusiast. In case you want to follow me on Twitter, which I don't use a lot, or connect on LinkedIn, those are my @. I'll bring them up again and I've added them to my profile within the platform. So bow tie jokes aside, who's this bloke? My background is as a technical and occasional solutions architect. I currently work in this space as a consulting principal at Modus, and I collect hobbies like a 2002 primary schooler collected Pokemon cards, that is to say, indiscriminately. Some of my hobbies, I'm an enthusiast about outdoor survivalism, and when I get time, I like to do things such as cliff jumping, scuba diving, rock climbing, and camping. I'm an amateur blacksmith, attempting my first hand-forged Damascus steel billet, and I enjoy cooking, and I'm looking at creating my own line of hot sauces, spiced salt seasonings, and jams. And I should probably cut back on the number of costumes I buy, with some pretty decent ones for Geralt of Rivia, Obi-Wan Kenobi with a full combat grade RGB motion sensing lightsaber, and a V for Vendetta, among many others. I'm recently been working on a chili farm where I'm growing over 40 varieties of chilies and over 400 individual plants. And of course, the part that you're all interested in, I'm a tinkerer, inventor, and nerd, whichever you prefer to call it, with a particular passion in the field of IoT. That's actually the desk behind me, where I have a whole bunch of prototypes or projects that I've been working on or have benched because I'm too busy. Some of the ones you can see there are things such as a continuous ECG. I'm building a mobile phone connected halter device effectively. RFID tracking for passive RFID tags, a LoRa-enabled ultrasonic distance sensor, accelerometers for fall detection, fluoro-soluble microcontrollers with ultraviolet light sensors, amongst many other things. A bit about my professional background. I started out in software development, doing a degree in software engineering, and I began to specialize in big data and IoT through a research thesis. After that, I started getting into a lot of hackathons. And even though you didn't ask for one, a fun fact is that I've participated in 7 hackathons, 5 of which were competitive, and 4 or 5 I either won or received a commendation award. So I definitely wrote down those hackathons that were through Telstra and the global IBM because bigger market. From these hackathons, is where I started specializing in emerging tech and IoT. And I was the co-author, one of the co-authors of the ACS 2018 paper, Australia's IoT Opportunity. So what do you actually do for work? Pretty much everyone. I typically provide the short answer of I'm in emerging technologies and cloud consulting. But funnily enough, that doesn't actually mean much for people both in and out of our field because of how diverse those disciplines are. So how can I succinctly describe my role when it's led me to design and or develop technologies in healthcare, mining, government, utilities, energy, emergency services, and smart waste, to name a few. But in the end, I think that's what it comes down to. The nature of IoT is diversity. I was able to perform these roles because we're applying intelligent capabilities to the world of things at an increasing rate. We have intelligent vehicles, semi-autonomous decision engines. We even have smart toasters. And I think most of the people here wouldn't touch a smart toaster with a 10-foot pole unless they built it themselves. For reasons I'm not going to rant about here, security and questionable necessity. But as developers, we have to be able to be flexible. We have to have biological plasticity. Something I've gotten reasonably good at is immersing myself in the field I'm being deployed into. When I start a new engagement in a new field, I'll hoard as much information as possible, and I'll try to absorb it all. So today I'll be outlining a framework that you can use to solution design and implement a new IoT project. And I'll be using a real world example of an IoT project that I worked on. But this framework isn't exclusive to IoT. It can be abstracted and applied to any problem solving requirement. If at any point it seems like I'm just pointing out the obvious, it's because I likely am. When you abstract something out enough, you can conveniently apply general broad sweeping statements and the chances are they'll be true. So in order to make myself seem more knowledgeable on the topic, that's what I've done. So let's establish entry criteria for this theoretical engagement. You have a client or a customer or a product owner. You have someone representing stakeholders effectively, and they have an issue that they need solved. In this case, using IoT. They've engaged you to simply provide the solution, but we all know that it's not quite so simple. So as a general breakdown of the framework, there are 4 stages. Each of these phases have some form of import, a distillation process where you elicit the details required for that phase, and then some form of output. Pretty generic, right? So let's dive in with the first one, which is the problem domain. This involves you diving into the field of the problem to understand everything you can about the context of the problem, why it's a problem, and what are the symptoms of the problem. Usually this requires you gathering all the information you can and learning as much as possible. This can be a tough one because sometimes stakeholders or clients may not see the value in you spending that time familiarizing yourself. You're not producing anything. But in the end, if there aren't any SMEs that you can utilize and you're going to be the one designing algorithms and a solution to solve a problem, you have to understand the problem and you have to understand the solution that you can use to solve it. In this example, the problem environment is that in extreme environments such as the northeast of West Australia, performing physically demanding tasks without being cognizant of your limitations in physical health can result in severe conditions such as dehydration, heat exhaustion, and even heat stroke, which can be fatal. So that's the problem, right? But what's the context of the problem? What are the symptoms, environmental factors? Why is it a problem? Some of the symptoms are like this. People literally work themselves to death. These articles talk about heat exhaustion, dehydration, and heat stroke causing injury or death. Why? Are the workers being forced to? Is it negligence from the employer? There has been and very well still could be conditions where the employers are at fault. But in this case, because the employer is coming to us to design a solution to prevent this kind of event, we're going to progress with the assumption that they're not at fault. So what happened? Do they not realize they're endangering themselves? Are they so focused on the task at hand that they become out of sync with their body? This is very possible. I have an interesting condition that means when I'm focusing on a task, I actually forget to breathe. My brain is focusing so intently on processing thoughts, and then when it stops focusing, I exhale and then inhale. It's something I've only recently discovered, and I could have possibly had it for years or decades. After actually writing that last sentence, I realized I was doing it and let out a big exhale. On the other side, is it monetary? These articles note that the fatalities are linked to contract work, or are they trying to maximize the number of work hours because they need the money or want more money? Do they not realize their limitations and they're just pushing themselves too hard? How can we protect people against something that they're not aware of or themselves? So any and all of these assumptions, firstly, need to be validated and verified with the client. They can clarify what you should focus on and whether any of your assumptions might be invalid. And they can even provide you with additional details for your research. We then want to distill this information into a mission statement, which would be the output of this phase. And that will guide our research into the problem's possible solution. So distilling all this information that we have into the mission statement, we can arrive at, we need a solution that monitors a worker when they're beginning to show signs of physiological suffering. We can send them an alert and action a task. Now that we have the mission statement, we should run this by the client and validate again to make sure that we're working on what they want us to work on. In this case, we get the go-ahead and we can proceed. So this mission statement is used to guide our solution elicitation. Before we begin, I think it's really important to differentiate solution environment elicitation and solution or technical design. In this stage, elicitation, we are looking at the abstract solutions that can solve the problem. And you should be within the context of the problem in this phase. We aren't designing a technical solution yet. So what do we need to solution? For this, we refer back to the mission statement, and we look at what components of it can make up a solution. In this case, we need to identify the occurrence of stress. What does this look like and how can we detect it? Then we need to send an alert. Who do we send this to? How do we send it? When do we send it? And then what tasks need to occur at the receival of that? Using my example, we're now researching how can we tell when somebody is beginning to suffer physiologically. Now, this part, much like the first, can quickly become a rabbit hole. So it's important to be broad on your analysis of the solution, but you also want to stay focused on contributing towards solving your mission statement and then refine your search to be specific to the context of the problem. So broadly, what are some signs of physiological suffering? We then focus on heat and stress and make it specific to workplace activities. So as mentioned earlier, we have dehydration, heat exhaustion, heat stroke, but I wonder if you can also tell the body is suffering stress in other ways. Well, with heat illnesses, what are the dependencies or stages to them? I knew about heat exhaustion and heat stroke from my time as a first aid instructor and lifeguard. And in my research, I found many references that mentioned that heat exhaustion and heat stroke are actually part of a heat-related illness spectrum, from heat rash all the way through to heat stroke. Articles often reference that one of the essential strategies to minimize harm and a good method to mitigate heat-related illness prevalence was hydration. So whilst heat exhaustion can occur independent of dehydration, in many cases, heat-exhausted people are dehydrated. And in many cases, it's actually a transition from heat exhaustion to stroke. So a good first step here is identifying increased body temperature and dehydration, because if we can monitor body temp as well as the hydration level, it might be possible to intercept heat exhaustion as it develops or before it develops. Body temp is pretty straightforward. However, there is a difference between core body temperature and surface temperature, I found out. So when we get to the technical design, we'll have to look for technical capabilities between the two. Now, dehydration, I would find out, is actually much more complicated. And for any students of the medical world watching, the nature of IoT is very exploratory. So some of the things I would say here might be controversial, or they might be less than 100% proven. I'm also, for the sake of time, grossly oversimplifying my description of research, so bear that in mind. Looking into research, I would find out that dehydration is typically determined through some decently invasive or cumbersome tests, such as a blood cell indices, urinary tests, or body weight change, not really things that you can pick up using IoT in the field. But there has been a lot of work in less invasive means, and one such that's come up quite a lot and provided a good amount of published papers on the topic is using galvanic skin response or electrodermal activity. GSR is the electrical characteristics of the skin, and using a test such as bioimpedance, which people familiar with body scans at gyms might know, it measures the impedance of an electrical current through the body. You can determine hydration levels. GSR can also be used to determine physiological stress, or how physically stressed your body is. This is thanks to skin conductivity's responsiveness to stimuli such as stress. And being able to determine stress and dehydration would be a fantastic way to protect the workers. So we know from our mission statement that we want to send and raise an alert. But who do we want to alert? How will we alert them? What is the alert? And when do we want to send it? These are the questions that we need to ask and we need to answer. So for the who, we discussed the possibility that the person may not be aware of the strain they're putting on themselves earlier. So alerting them would be valuable. But what if they were aware and willing to work anyway? How do we protect them from themselves? For this, we came up with the idea of either alerting their supervisor or their work partner. This does raise a number of ethical questions, such as the potential impact of our solution on the user. But upon discussing it with the client, we deemed that out of scope. For the purposes of our solution, our job is to keep the person safe, and the organization will work on the logistics of ensuring the workers are not negatively impacted by our technology. So with all this in mind, we went for an early indicator to the person themselves. And then if conditions did not improve, they would receive another alert alongside an alert to their direct supervisor. So what's the best way to receive this alert? Text, email, smoke signals? Ideally, we want something that can get their attention even if they're focused. And furthermore, the reliability of sending a message to a phone isn't really good enough. They might not have it on them during the shift. They might not want to install an application for work on their personal phone. They might just ignore it. So and we also found out from the client that all the workers do have a tablet they use for their tasks on shift. And of course, they'll have the sensing device as well. So for this stage, we determined that alerting through the wearable and through the tablet will be the way to go. So what tasks do we want to action? Ideally, the first message should be informative. You are now at risk. We want them to acknowledge that they've received the message, so we know that they've received the warning. And the message will advise them to go to a cool area, rest, and rehydrate. By the time it gets to the second, they're at an increased risk of a serious illness, and we need to take steps to protect them. So they'll be instructed to rest, go to a cool area, consume water over a 30-minute period, and their supervisor will also be notified. I know how this sounds. You're sitting there like, Josh, you can't dub in the blokes. They're just trying to make a living, or snitches get stitches, mate. But we aren't being malicious dictators that want to interrupt and annoy people on their job. And this isn't us getting in the way of somebody doing their regular duty. By the time these alerts go off, the person is at significant risk of a serious illness. So with all that in mind, now we want to produce a set of solution theories that will be the output of this section. What we have is we will use heart rate and body temperature to detect stress. We'll use GSR to determine hydration and stress. And we will send the first alert to the person over watch and iPad, wearable and tablet. And we will send the second alert to the person and their supervisor over the same means. The first message advises the worker to rest in a cool shaded area and drink water. The second message instructs the worker to rest in a cool shaded area and drink water. So now that we have the solution theories relating to the three stages of the solution, we want to validate them with the client. In this case, they were happy and they recommended some slight adjustments, but we were able to proceed. So we now formed an image of the solution that we're going to be building to solve our client's problem. And here's the fun part, looking at the technology to implement that solution and design what our technical solution will look like. So we have the solution theories, and we now need to look at the tech and whether or not we can build them out, because at this point, the solutions might not be technically feasible with the technology that we currently have at our disposal. So one of the first things we'll be looking at is any restrictions. The second is the available technology that we can use to design the solution. And then finally, designing the technical solution itself. I won't be going into any details or depth about the development itself. I'm mainly going to be focusing on the relationship between the solution and the tech. For good coding practices, design practices, software architecture, you should go and read Uncle Bob's books rather than watching this presentation. So we know we want to collect heart rate, body temp, and GSM. For this, we would need some biometric sensors. So the first thing we should ask ourselves is what restrictions are in place. And of the restrictions, the first thing you should consider is, does the client have something in mind or something in the field already? And then you have your additional considerations such as, are there any water or dust resistance, budgetary, battery life, peripheral requirements, things like that. In our case, the client was happy for us to make suggestions as to the biometric wearables, but the system had to integrate with their iOS tablets in the field, as well as they had to be commercially available. So we couldn't hack together our own perfect system and manufacture that. So those were our restrictions, but we still had the design considerations to have below that. So starting broad, we were looking for commercial wearables that can work with iOS. We wanted to focus on ones with biometrics And this gave us a list of the Apple Watch at the time, the Fitbit Ionic, the Polar Smart, the Garmin Fenix 5, and the Samsung Gear 3, Gear 3, S3, as well as a specialized medical grade wearable we were trialing as well. From this, we wanted to refine it to ones taking into consideration water and dust resistance, battery life, product costs, peripheral requirements, and development costs. As procurement costs for all these devices were similar, the product cost was less of a factor. We ended up ruling out Polar Smart, Fenix 5, and the Samsung Gear due to availability, development costs, and lacking specific sensors we needed without peripherals. And we also ruled out the medical grade wearable due to battery life and IP rating. It just wasn't made for the conditions that you would see in the weather and dust and battery life that you would require on prolonged periods of shifts. So that left us with the Apple Watch and the Fitbit Ionic. With an understanding of what wearables we can use, now we can look at the solutions we elicited from the solution environment, and we need to get a technical design. So firstly, this requires us coming up with algorithms for the solutions that we identified, followed by our general cloud and system architecture. For this, let's look at designing an algorithm first for normal heart rates. So generally, heart rates sit between standard ranges, but they actually also differ based on fitness, age, weight, gender, and physical state. So at rest, normal, active, all of these factors need to be considered. So instead of designing a very specific heart rate zone, we wanted to make one based on a sliding scale that normalizes to each person. It establishes a baseline for the person and then uses a scaling modifier to adjust the general zones for each state. That way, you're not getting false positives when suddenly the work becomes physical. It just transitions them into a new state, identifying that they're in a significantly different period. So that gives us the algorithm to apply for heart rate zones. The surface body temperature itself is pretty straightforward, but because some people run a little bit hotter or colder than others, we may as well apply the same logic as the heart rates. Establish a modifier per person, apply that to the general thresholds. Although as temperatures are much lower than heart rates, the variance from the standard was considerably smaller. And then we'll also look at the heart rate when the temperature is spiking, as combining both metrics was shown in research to be more reliable than just temperature. So now we need one for dehydration and one for stress. Unfortunately, we couldn't get galvanic skin response from the Fitbit or Apple, which means hydration itself is out. However, we found an equation where we can use the heart rate and body temperature to calculate what's called a physiological strain index, or PSI, different PSI for any scuba divers in the crowd. And that can be used to identify people at risk of heat exhaustion or strain. So we, with that variance in what we had discussed with the clients previously, we looped back with the client to make sure they were happy with what we were doing. In our case, they were happy that we had the 3 measurements and that would sufficiently indicate the well-being of their employees. And the reality is that finding an alternative or having to bespoke make the hardware would draw out for too long, and it wasn't what the client wanted in this phase of their project. So now that we have the technical designs for the algorithms and how to detect when somebody's beginning to be stressed, we need to look at the technology design for how we'll be alerting them. We know from the solution environment section that we did earlier that they will have iPads, and of course, they will have the wearables, both of which have vibration motors and can support mobile notifications when linked with the phone. So as part of each stage, we'll include in our technical design for wearables, the alerts and the iPad alerts. The first stage being to the end user, and then the second to the end user and their supervisor. And finally, the final part of the solution design was the actioning component. So the users received their initial alert and acknowledged it, but we had to consider what if they didn't acknowledge it. So we decided in that case, we would resend the alert every 15 seconds for 1 minute. And if there was still no acknowledgement, then we would escalate that as not responding to their supervisor. If they do acknowledge it, however, then the device would just continue to monitor them. And if their state hadn't improved for the next 30 minutes, the second alert is then sent. We explored the possibility of utilizing the device's inbuilt GPSs to see whether they'd moved to a shaded area that could be identified. But the client ruled this out and said it was a little bit creepy. So we left that out. As we'd been doing a kind of micro validations this whole time with the client, we didn't have anything big or that they weren't aware of for this stage of validation. But usually this is where you validate all your technical designs with your assumptions as well. But they were happy, so we got the go-ahead to move forward into implementation. So now we get into the solution implementation itself and the continuous validation. And this is something really important to note. Up until now, the primary validator is your client, customer, product owner, the representative of the stakeholders, the person engaging you to develop this solution. Now this changes to the end user. You're no longer designing the solution, and by the time you get here, the stakeholders should be happy with everything you've designed. Otherwise, you would have reviewed it until they were. Now you need the support of the end users, because if they don't like your solution, they won't use it. The majority of the time, your client will fully understand this, but sometimes you will work with difficult people who don't understand the feedback from end users relating usability is more important than the feedback from the product owner, relating specifically to usability. It may be a controversial opinion, but my thoughts are the stakeholders have signed off on everything that you've done to date. And as long as you follow that plan, the client should be happy. And they usually are. That's not to say the client gets no say, but because product owners are an important part of the development lifecycle. But remember who will be using your solution. So at this point, I'm not going to go into the different product development life cycles. I'm not going to open that can at all. All I will say is make sure every few weeks you're validating the solution with your end users. So essentially do user acceptance testing. There's nothing worse than working on a project, coming up with something awesome only to have nobody use it, because the vision fits with the stakeholders and not the end users. So that's it. I know the framework is very top heavy, but I'm not here to tell you what's good development practice. That is far too broad. So yeah, if you found these slides pretty, they're much nicer than I usually develop. It's because I use this template from Slide Carnival. I'm required by law to have this in. So thank you everybody for taking the time to dial in and watch my speech. Special thanks to Ali for inviting me to speak, and feel free to reach out via LinkedIn. I will be hanging around for the networking.
Amazing. Thank you so much, Josh. That was awesome. I love how holistic this product is, and it really speaks to me because it's exactly what tech is for, helping us do cool things or helping us in some way. I love the quote at the beginning as well. It always reminds me of creativity is intelligence having fun, and that's exactly kind of, and that's in tech as well. So I loved that you'd get it towards tech. We do have a few questions, some of them about the IoT and some of them just about chili. So we'll start with the IoT ones. What sort of device testing do you do to test devices that need to operate in extreme heat like a desert?
Cool, good question. For this depends entirely on the client. I haven't done any, I've been fairly fortunate in that I haven't had to test anything myself. Either they're looking for a commercial product, in which case the client will specify, the base requirements of the hardware. They'll say it has to have been rated or has to be able to function in this kind of environment. One of the projects I did work on partnered with a university. They're being fitted to very, very big vehicles. And those very big vehicles have a lot of vibration. So all of the hardware that went on had to be stress tested for vibration. So, but unfortunately, I never had to, fly out and hang around in the 43-degree heat to test anything like that. But yeah, usually the client will specify either like standardized requirements or there'll be a hardware partner that's providing the actual solution that they will test everything up to scratch.
Makes sense. Awesome. Thank you. What's our next question? From Peter, do you see value in soliciting end user feedback earlier?
Yeah,
in the
100%. So
cycle?
if I obviously being in dev, in development, I usually follow Agile and Scrum. As part of that, from first release, we're doing UAT and usability testing. That's my background. I've worked heavily in Scrum teams with UAT as part of sprints, but I realized the reality is in some development life cycles, you're not going to have the opportunity to use that. They might be using waterfall for whatever reason, but 100% that in the end, if somebody, you should be getting the opinions of the person who's going to be using it, because if they don't like it, they're not going to use it.
Totally. It's all about user-focused design, and they're the ones that know best about what their situation is too most of the time. So, yeah, definitely. So one from Animesh Dubey here. How did you address the inherent cybersecurity requirements of production-focused resource companies? Did you face any restrictions with respect to network and communication
absolutely.
protocol?
The interesting thing is the security requirements vary greatly between projects and clients. It's usually more down to the specific requirements of the company that you're working with than kind of overarching government, that kind of thing. So I've worked in some where it's been, ridiculously locked down to the point where you can't be productive because you have to work in a specific location or you have 3 jump boxes or something like that. Generally, we always try to apply best practices. We'll always say, as a default, encryption at rest and in transit. Sometimes those requirements are significantly higher, but generally, sorry, I think I deviated from the original question.
All good.
Yeah.
I think the general were there though. Thanks, Josh. Last question on the actual product. Is this specific to stress at work? How will it determine if it's exercise that's increasing the heart rate and dehydration level?
Yeah, so this was specific to the workers were on shift in their day-to-day role. They would take the wearables when they began their shift, and they would take them off at the end of their shift. So it wasn't factoring in that they would go to the gym or something like that.
Yeah, awesome. And again, I really loved this because there's so many applications for it, I think, as well. Definitely IoT and healthcare. It's a massive field. AI in healthcare as well, another massive field, and we had a meetup about it not long ago. So yeah, there's so much happening in that area, and super excited about where that kind of takes us, because I'd love to have non-invasive surgeries. There's just really, the sky's the limit. Awesome. So now I'd love you to take a breath. Firstly, bit disappointed you didn't wear a bow tie as well, Josh. And we've got a couple of questions on the chilies before we wrap up, Michelle. So, do you water your chili manually or have something automated?
I still water them manually. I have done my research into hydroponics and aquaponics. Obviously, the end state, so I'm in the design phase at the moment. End state will be a fully automated aquaponics system, because obviously balancing the water chemical balance and feeding the fish are the only two kind of external influencing requirements of an aquaponics system. So, auto deployable lime to balance the nitrate, and ammonia levels of the water, as well as feeding the fish.
I didn't ask that question, but I upvoted it because I spend half an hour every day watering my garden, so I was hoping you were going to give me an easy way.
Takes some time, doesn't it?
There are a few options though. And last question: what's the highest Scoville unit chili you have ever grown?
I'm growing up to the Reapers, so the current Guinness World Record holder officially. I have some hot sauces, which include Pepper X, which is kind of the alleged. But that is proprietary to the Hot One show, so they haven't had it officially tested. But yeah, I've got about, I think, 20 or 30 Reaper plants.
Awesome, and that's it. Thank you again, Josh. And yeah, hang around, have a chat to Josh. After this, I'll leave you with Michelle, who's going to end this for us. Thank you very much.
Thank you again, Josh and Rajeev. And keep your questions going in the chat if you guys have anything more to say to them. Or you can reach out to Developer Ali or myself, or Developer Steve, indeed, if you have any questions for us or the speakers after. I think we've recorded these. I think I'll get a confirmation from Developer Ali, but I think we'll be posting these up on YouTube anyway. And our previous talks from the AusIoT and Melbourne IoT meetup are on the YouTube page as well. So someone could post that in the chat. That'd be awesome so everyone can see. Just the last part of today is to ask if anyone wants to go off mute and share a project that they've been working on. It could be, maybe you can answer my question to how you don't water your garden for half an hour every day. If anyone's done hydroponics before, that'd be cool. Put your hand up if you want to share a project. What do you mean put your hand up? Do they have hands up in remote? Is that a thing? No, I don't think so. Maybe just go off mute. But if not, if there's no one here to share a quick present, it's a thing. Apparently it's a thing. Oh, maybe because I'm presenting, I can't put my hand up. But if you are in the chat, you can put your hand up. Let's see. I think someone put their hand up. Anyway, I don't know how to use this thing, so I'm going to have to leave the IVF crew to bring anyone up.
Yeah, there's no hands up, but I think we can talk about that in the networking as well. Thank you. Thanks.
I was just, okay, so Fashad just said, yep. Does that mean you want to talk?
Oh, I think he was just agreeing that it does exist, the hands up thing, so.
Okay, so no, he doesn't want to come up. That's fair enough. So the other thing I was just going to say is we're going to put the tables back on then. And then so you're able to continue networking. Sorry about my fidget spinner, guys. I just realized that came in the camera, but this is for me to stop banging on the table. So we might just close the presentation session and head back into the tables for the next 15 or so minutes. It was really cool to have you guys in today. I really love the Q&As that were coming through. It's always great when you're doing a virtual presentation to have Q&As coming, and I love the upvoting thing too. So like we said, we're probably going to start this back up again in February. We might even get Rajeev back at some point to finish the other half of your talk. That'd be awesome.
Yep.
And anyone else who would like to speak or would like to recommend a speaker for the IoT meetup, please let us know.
Yeah,
that's all I had to say. What about you guys?
Thank you very much, everyone. Oh, Steve?
Oh, I just wanted to say a quick thank you because this was the first year that this whole thing started. So I literally just realized that. So
Wow.
on behalf of all of us, just thank you. Thank you for coming. Thank you for making it awesome and just geeking out and talking IoT stuff. So yeah, that's all I wanted to say.
Awesome.
Yeah. How, imagine when you guys started, was it in February or something? You had your Melbourne meetups. Could you have imagined that by December we would have done 6 months online?
But we only had one IRL event, one in real life event, and then everything everything went agile. Agile, totally agile. And then there was maybe a month or two where we were figuring out just everything, and then we started the online thing. So just thank you to everyone for coming and making it awesome.
Thank you.
Yep, definitely. I totally agree. Thank you. Happy holidays, everyone, and we'll see you in February.
Yeah, chat you on the table.
See you now.
See ya.